Hi everyone, welcome to the next session of Geotechnical Engineering 2 in earth pressure theories. Up to now, we have discussed the various type of concept based on active earth pressure and passive earth pressure. We have discussed about the various type of conditions when the backfill having different type of parameters. That means when the backfill is uniformly submerged or when the backfill is having water table or when uniformly load is acting on the backfill. In those conditions, how the earth pressure is acting on different types of walls we have discussed up to now. In today's class we are going to discussing about the one more problem, that is Culman's graphical method. In Culman's graphical method in Culman's graphical method, based on a curvature, we are finding the how earth pressure is going to be drawing by using a graphical method that we are going to considering here. And this Culman's graphical method is also based on the Coulomb's graphical method. In Coulomb's theory, directly we have taken the calculation of active earth pressure, calculation of passive earth pressure. In this Culman's graphical method, by using some graphical representation, we are finding the how the pressure is acting on the wall that we are going to discussing in today's class, as well as we will solve one more problem based on the important concept such as in Rankine's theory. Okay, coming to this Culman's graphical method, if you observe here, Culman's curve is the curve used to find out the active earth pressure and passive earth pressure in retaining walls. Culman's curves are drawn using the Culman's graphical method. There is a retaining wall. In this retaining wall, the pressure will be acting on the wall based on assumptions, various type of assumptions based on graphical method. We are finding the pressure acting on the wall. And well, before going to the brief discussion of Culman's graphical method, this is the how we are finding the active earth pressure or passive earth pressure will going to be act on the wall by using this diagram. We are finding this is a graphical method for accurate or for practical purpose of calculation of earth pressure acting on the wall. We won't use this type of graphical methods. Majorly we'll use the Rankine's earth pressure theory to calculate the how much amount of lateral pressure is going to be act on the wall. And again, if you observe here, suppose I am assuming that here this is the height of the retaining wall H, and the height of the retaining wall I am taking here two parts such as A and B, and B is the bottom of the retaining wall height and A is the top of the retaining wall height. And if you observe here, this is the level horizontal ground surface. From this level horizontal ground surface, I drawn one line beta making an angle. This is a horizontal ground surface. Okay, as well as, and I am making one more angle J line. This parallel to this ground surface. Suppose this is the your horizontal ground surface. For this horizontal ground surface, we are drawing one J line into the ground surface. And if you see here, these are the retaining wall. For this retaining wall, how the active earth pressure that we are going to act, that step by step procedure we will discuss in today's class. If you before going to discussing this pressure, first we are assuming the one failure of the soil wedge. Suppose this is your retaining wall and this is the backfill of the soil mass. For this backfill of the soil mass, due to wall moves away from the backfill, the soil what available here, it makes a plane failure wedge. In failure wedge, how it is acting on the wall, that we are going to discussing in today's class. By step procedure, we will see the how the pressure is acting on the wall. Okay, in simple way, if you want to know means, first what we are doing means, we are drawing one angle of inclination with the horizontal ground surface, that is B, and next we are drawing one more J line into the horizontal ground level of the soil mass at the bottom, and we are assuming one failure of the soil mass. That failure of the soil mass is A, B, C, and this is the failure of the soil wedge we are assuming in first condition. After that, we are taking one more failure wedge and one more failure edge and one more failure edge. In stability of analysis of slopes in Swedish arc method, we consider different types of Swedish circle to know how much amount of normal pressure acting, how much amount of shear force, shear stress is acting. Based on similar condition, here also we are assuming different types of plane wedges. For this plane wedges, for this failure corresponding to this J line, we are drawing some parallel lines. After connecting different types of failure wedges with the different types of the failure position, we are finding the active earth pressure in Culman's graphical method. Okay, by seeing the individual point, we'll know the how the earth pressure is observing in Culman's graphical method. First, if you observe here, the first point is procedure for constructing of this Culman's graphical method. First, these are the steps, step by step, that we have to write. Okay, if you observe, the first step is draw ground line, failure line, and earth pressure line. That is beta, gamma, J angles respectively. And if you come to this diagram, this is the height of the retaining wall. For this retaining wall, we are writing one draw line, as well as that means J line, as well as we are writing one more angle of inclination, making an angle of beta of the horizontal ground surface, and failure wedge C, A, B, C. This is the failure wedge of the soil mass we are assuming for this retaining wall. And next, if you see here, consider any trial wedge ABC1 and measure the length AC1 as L1. Okay, if you can take any trial wedge ABC1 or ABC2 or ABC3 or ABC or ABC4, any trial wedge we are considering, and we are assuming that the length of the failure wedge at top of the ground surface, we are taking it as a particular length. Suppose if you are considering the ABC1 wedge, if you are, suppose I am taking this ABC1 edge. For this ABC1 wedge, soil wedge, I am taking this length of the wedge as L1. Next, I am taking one more failure wedge. That one more next failure wedge is ABC2. And from this failure wedge, I am taking this length of the soil mass as AC2. Length of the soil mass as AC2 is L2. Next, I am considering one more soil edge ABC3. ABC3. Again, from this we are having one more soil wedge length, that is L4. And here taking one more point C, ABC. That length we are having L. These are the second point and third point we are considering for the Culman's graphical method. And next, if you observe here, calculate the weight of wedge ABC1 and plot it at point E, that is BE1 equal to L1. BE1 equal to L1. What we are doing means, if you take this soil wedge, for this soil wedge we are having certain amount of weight. That certain amount of weight we are representing a point on this Culman's graphical method. How much distance we are taking means, from B to E we are taking a point, the weight of the soil wedge. From this B to E we are drawing a parallel line to the J line to this failure wedge. Okay, what we are doing, if you observe this point, calculate the weight of the wedge ABC1 and plotted point E, that is BE1 equal to L1. BE1 equal to L1. This is the B point and this is the E point. From this B to E with the length of L1, we are drawing here one point. Okay, from B to this L distance, L1 distance, we are drawing a point here, and we are drawing a parallel line corresponding to this failure wedge. Okay, next, consider all such lines BC2, BC3, BC4 and corresponding points E1, E2, E3 and E4. Again, if you see here, first point BC1 we are having the length as L1. Okay, that means this is the triangle wedge ABC1. For ABC1 we are having the length of AC1 as L1. From this point B2 with the L1 distance we are creating the one point. For this creation of the point, for this J line parallelly we are drawing one more point for this corresponding C1 length. Again, if you come to this second trial wedge, that is AB C2 for the second trial wedge, again with the length of L2. Again from point B2 with the length of L2 we are drawing one more point here. From this point we are making a one more connecting point for this second failure wedge of the soil mass, such that for all type of corresponding points with respect to the length of the trial wedges we are drawing from this point. Okay, this is the fourth point and third point. And if you see here from fourth point we are taking all such type of points BC2, BC3 and BC4. One more time I am explaining here. First we are taking the three line, that is horizontal ground level, and making angle of inclination beta line and the failure wedge. After that one failure wedge we are considering. For this failure wedge, how much distance AC1 is there? This much distance from this B to this line we are drawing a one point. After the second triangle we are taking, and again for second triangle AC2 length how much it is there, we are representing one more point here. For this point corresponding to that particular failure of the soil wedge, with respect to the J line parallelly we are drawing the corresponding lines such that we are connecting different types of points, that is E2, E3, E4, and how many number of trial wedges you are taking, that many number of failure planes we are drawing for the graph. And next, if you come to the fifth point, through E1 draw a line parallel to the J line which cuts the BC1 at point F1. BC1 at point F1. Okay, from this J line we are this is the point we are kept here. From this point, for this BC line we are touching one point, that is F1. Okay, already you have understand this, we have explained this point. From this B to E1 AC1 length we have drawn one point. From this one point to for this particular point we are attaching a one point for this ABC1 trial wedge. Next ABC2 trial wedge we are having E2. That E2 again we are drawing one more point for the F2. Next we are having the AC. From AC again we are drawing one more point AC3 for this C points, in such a way that for all type of trial wedges we are drawing all type of points. Next draw similar lines F2 E2, F3 E3 and F4 E4. And again if you observe here, from this E1 to F1, E2 to F2 and E3 to F3. Suppose if you want to use here term E to F and E3 through F3, E4 to F4, such that corresponding points were with drawing. Where these F points are there, from these points to smoothly we are withdrawing a curve. Okay, for this corresponding points where it is available here, from these points we are smoothly drawing a curve touching this failure planes. After touching this failure planes, after drawing of one curvature, we are writing a tangent to that particular curve. Writing a tangent to that particular curve. The particular curve of the tangent will give the active earth pressure in Culman's graphical method. Okay, if you see here, draw a tangent to the Culman's curve which cuts the curve at a point E. Okay, at point E. If you observe here, this is the graphical method. For this graphical method, if you draw the smooth curvature in this like that, and if you cuts the curvature at particular point, the particular point will give the corresponding pressure. Okay, corresponding curve. Draw FE line parallel to the J line where the point failure plane FE is there. For this correspondingly we are drawing a failure line with respect to parallel to the J line where this FE is the active earth pressure line. Hence active earth pressure is calculated as PA equal to gamma into H. PA equal to gamma into H. Then we will form the triangle. Based on triangle, we are having the active earth pressure as half into gamma into H, where gamma is the unit weight of soil. So in this way we can find the active earth pressure using the Culman's graphical method. Okay, this is the explanation of the Culman's graphical method. Otherwise, by writing the diagram, I will explain here neatly. Okay, and again, suppose if you see here, this is your horizontal ground surface, and this is the J line, and this is the making of an angle of inclination of the beta to the horizontal ground surface, and this is the A point, and this is the B point. First, I am assuming one failure wedge of the soil mass. That failure wedge of the soil mass, suppose this is A, and this is B. That failure wedge of the soil mass we are taking it as AC1. This AC1 we are taking it as length of L1. Next we are taking the one more soil wedge. That one more soil wedge is nothing but we are having AB into C2. For AB into C2 we are having the length of the soil wedge as L2. Next like that we are having one more triangle. That is length we are having the L3. So in such a way that we are drawing different types of graphs of the soil mass. Now what we are doing means for AC length from this point we are correspondingly drawing one point, and based on this weight of the wedge we are assuming one failure wedge of the soil mass. From this diagram too we are drawing a parallel line corresponding to this point. Suppose if you are assuming this as E1 and this is F1, and again if you come to this second point, from the second point to here we are drawing one more point, that is E2 into F2, as well as in third point we are taking the one more point, like that in such a way that we are drawing the all points. After drawing all points, by using the curvature we are drawing a point corresponding to this all particular points. For these points we are drawing a curvature where it touches the curvature from this point to this J line. Okay, this is your J line. From this J line we are drawing one more line. This portion of the triangle will gives the active earth pressure acting on the wall. That active earth pressure PA equal to half into gamma into H square. This is the how graphically we are constructing the active earth pressure. We are writing in our real time by using the scale. We should have to write by using scale neatly. Should have to write this construction diagram by given the procedure. Okay, up to now this is the procedure for calculation of the active earth pressure, and the active earth pressure we are having PA equal to half into gamma into H. In the same way we can calculate the passive earth pressure also for Culman's graphical method. Okay, up to now this is the topic for Culman's graphical method. Next we are having one problem. Okay, we will solve the one problem. We will solve the one problem based on the active earth pressure in Koju soil based on the Rankine's earth pressure theory. In Rankine's earth pressure theory, in Koju soil, how the lateral pressure is going to be vary, that we will see in this lecture. Okay, and if you see here, determine the stresses at the top and bottom of the cut shown in figure. Also determine the maximum depth of potential crack and maximum depth of unsupported excavation. I will show the image. After seeing that image, you will understand the given parameters. And again, if you come to here, this is the diagram given here for calculation of active earth pressure and the depth of potential crack as well as unsupported excavation of the soil mass. Okay, this is the diagram given in the problem. This is the problem. I have taken it from the I have taken it from the Culman Terjagi. That means soil mechanics and foundation engineering by Aurora. Okay. And if you see here, geotechnical engineering by Aurora. And if you see here, given data I am writing here, the given data is given. Okay, cohesion of the soil mass, given cohesion of the soil mass C equal to 20 kilonewton per meter square. Cohesion of the soil mass C equal to 20 kilonewton per meter square. Angle of intersection phi equal to 12 degrees. Angle of intersection phi equal to 12 degrees. And unit weight of the soil mass gamma equal to 18 kilonewton per meter cube. and height of the wall h equal to 4 meter. Height of the wall h equal to 4 meter. These are the given steps in the problem. For this, first we should have calculate the active earth pressure. Next we will calculate the depth of potential crack as well as unsupported excavation of the soil mass. Okay, in active condition, active condition of cohesive soil, in active condition of cohesive soil, the earth pressure is in active condition of cohesive soil, the earth pressure is PA equal to Ka into gamma into Z minus 2C into square root of Ka. This is the formula we are having for determination of active earth pressure in cohesive soil. Otherwise, the formula you can write it as Pa equal to gamma Z into cot square alpha minus 2C into cot alpha, where Ka is the coefficient of earth pressure in active condition, Kp is the coefficient of earth pressure in a passive condition. First we will calculate the passive earth pressure, next we will calculate the at a depth Z equal to 0, at a depth Z equal to 4 meters, the active pressure we will calculate. After depth of potential crack, depth of unsupported excavation we will can calculate. Okay, next from this we are having the active earth pressure. Before calculating this active earth pressure, we should want to calculate the coefficient of earth pressure. That coefficient of earth pressure Ka equal to cot square alpha equal to 1 by tan square alpha. Otherwise you can write it as 1 minus sin alpha divided by 1 plus sin alpha. From this, Ka equal to 1 minus sin alpha, they are given in the problem as 12 degrees. 1 minus sin 12 degrees divided by 1 plus sin 12 degrees. Okay, from this coefficient of earth pressure, Ka equal to, we are getting this value as 1 minus sin 12 degrees divided by 1 plus sin 12 degrees. Okay, we are having this coefficient of earth pressure Ka as 0.655. From this we should calculate the active earth pressure. That active earth pressure Pa equal to Ka value already we are having 0.655, and where Ka gamma is the unit weight of the soil mass. That unit weight of the soil mass we are having 18 kilonewton per meter cube. That is 18 into Z minus 2 into, where C is the unit coefficient of the soil mass. The unit coefficient of the soil mass they will given as 20 kilonewton per meter square. That means 20 into cot alpha coefficient of active earth pressure, that is 0.655. From this, the active earth pressure Pa equal to, we are having 0.655 into 18 into Z. Okay, I am having this active earth pressure as 11.79 into Z minus 2 into 20 into 0.655. Okay, we are having this value as 26.20. Okay, 26.20. If you see here, Pa equal to 11.79 Z minus 26.20. This is the active earth pressure at any depth of the soil mass. That is active earth pressure. Active earth pressure at any depth of soil mass. Active earth pressure at any depth. Next we will calculate the active earth pressure at the top of the wall as well as at bottom of the wall. Okay, I am writing here at Z equal to 0. At Z equal to 0. At Z equal to 0, the active earth pressure Pa PA equal to 11.79 into Z, 11.79 into Z minus, okay, next 2C Ka, square root of Ka we are having 2C into square root of Ka, we are having nothing but Pa equal to 11.79 into, and Z equal to 0, we are having this value as 0, minus 2C into square root of Ka, already we have calculated 2 into 20 into 0.655, that we are having 26.20, 26.20, okay, answer we are having this value as 26.20. That means the active earth pressure at the top of the wall we are having Pa equal to 11.79 to Z equal to 0, we are having 0 minus 26.20 kilonewton per meter, 26.20 kilonewton per meter at top of the wall. Okay, 1 minute please. Pa equal to Ka into gamma Z minus 2C into square root of Ka. Sorry, Pa into 0.655 into here square root of Ka. Hence why we may have this as 1 by 2, 0.6522 1 by 2. That means 0.655 into 18 into 1. Okay, so 11.72. Okay. Square root of 0.655